Now, what do I mean when I say we'll solve this using integration? It primarily means that we're trying to derive the equation s is equal to ut plus half at square in a different way. That's it. But yes, the method and the and the way we derive the upper limits and lower limits for time, that is really important. So v square minus u square is equal to 2as. Since this is released, u is equal to 0. So b square minus 0 is equal to 2as. Velocity is acting downwards. Displacement is acting downwards. Acceleration due to gravity is also acting downwards. Therefore, exactly, acceleration would be equal to plus g. So acceleration here is equal to plus g. And now for convenience of choosing the variables, I have taken s as y, which means this vertical displacement is considered to be is taken as y, because we are more used to dx and dy, just for a simple reason. So what is v square is equal to 2gy? What is v is equal to root of 2gy? Now, we know from the definition of velocity, which is equal to rate of change of displacement, time rate of change of displacement, d by dt of y, or dy by dt. Transposing v, we have dt is equal to dy by v. And now let's plug in this v is equal to root of 2gy in here. So we get dy divided by root of 2gy. And what is special with dy divided by root of 2gy? This equation is now in the variable separable form, which means the LHS has variables in dt alone and the RHS has variables in dy alone. So yes, that being said, dt is 1 dt, the constant, and 1 is the constant, root of 2g is also constant. So the only variable here is root y, which means that root of 2gy is expressed here as root of 2g into root of y. Now, dy by root of y can further be written as multiplied by 2 and divided by 2. Okay. So this eventually becomes 2 by root of 2g into 1 by 2 root y into dy. Why am I making this? Because what is d by dx of, okay, what is d by dy of root y? It is 1 by 2 root y. Therefore, what is integral of 1 by 2 root y dy? That's equal to 1 root y. So now this clearly is in the variable separable form, and thus can be integrated, So when we bring in the integral, we have integral dt is equal to 2 by root 2g into integral of 1 by 2 root y dy. What comes here is the most important point that I was talking about. Putting up the limits for definite integral. So time varies from ta to tb for any time, and dy varies from y1 to y2. Yes, you can also choose t1 to t2. The reason why I chose ta and tb is because of the fact that we have t1 and t2 given in the question. So that might cause a bit confusion here. Okay, right. So applying the lower limit minus the upper limit minus lower limit, tb minus ta, y2 root of y2 minus lower limit root of y1. So TB minus TA is equal to 2 by root 2g into root of y2 minus y1 can be written as now, okay, now it's very basic, but yet, so 2 is root 2 into root 2 by root 2, root 2 by root 2 is 1, and therefore we have root 2 by root g into root of y2 minus y1. Now see, solving this can be done by considering either of these three cases. But with case 1 and case 2, the calculation becomes really complex. So I will solve this using case 1 and case 3, which is the most easiest way to do this question. Okay. So, but what is case 1, case 2 and case 3 that I'm talking to you about? So case 1 is TA equal to 0 to TB equal to T. Excuse me. Correspondingly, y1 is equal to 0 to y2 is equal to h. TA equal to 0 to TB equal to T1. Lower limit 0, upper limit h by 2. Lower limit T1, upper limit T. Lower limit h by 2, upper limit h. Yes, I do understand that things are a bit ambiguous here. So just to make sure that you get the clarity on this. And if you are writing this along with me, I would suggest that you please make a table of, take a copy of this one as well, because this will really help you in solving. I think there are one or two questions that are based on the JEE advanced PYQs that we're trying to do. Not in this chapter, but in laws of motion, which will have very similar foundation of upper limit, choosing limits for time. Very important. Okay. So what is T? T is the absolute time at which object hits the ground. That is when y is equal to h. What is T1? Is the absolute time at which object reaches halfway point, or when y equal to h by 2. What is T2? Is the time taken to fall from y equal to h by 2 to y equal to h. That is duration of the second half. Okay. Not clear? We'll look at this in a different way. When I say clock time, what I mean is, if we analyze this motion using a clock here, right? Using a clock here, a ball is dropped, and that time is considered as t is equal to 0 here. The first half happens, it reaches h by 2, and then the second half happens, it covers the next h by 2 and eventually reaches the ground. So throughout this motion, we are making observations of time here. Okay. And those observations can be divided like this. When the time is t equal to 0, the height reached by the body is the start position, which is y equal to 0. Exactly, initial displacement is 0. When the time on the clock is t is equal to t1, say t1, the body has reached halfway point, or the displacement so far is h by 2. But when the clock says t is equal to capital T, it has reached the bottom point or the ground. Okay. Now let's rewrite this. The time when object hits the ground is capital T. The time when the object reaches the halfway is T1. The time taken to fall from h by 2 to h, the second half, is T2, which is actually equal to capital T minus small t1. This is the concept. Trying to understand this is really important. It might appear to be very easy and very subtle, and you might be surprised what is so interesting in this. But trust me, when you do questions on this topic, topics connected to this, especially the ones in JEE Advanced, choosing the limits it's really important, and I see most of us making a mistake there. So I don't want you to go through the same mistake again. I've given a very clear explanation. Not an explanation. I'm just giving you a clear indication that such an error is of very high probability. Okay. Having said that, I would like to rewrite this in a different way. T is the moment the object hits the ground. T1 is the moment it reaches halfway. T2 is the duration of the second half of the fall. That is how long it takes to go from H. Oh, my bad. I was meaning this. From H by 2, H over 2 to H. And we are asked to find out the relationship between T1 and T2 and not T. And we don't know. We might have a question in the future which is based on connecting T1 and T2. So that's why I just added all three here. Okay. Now, I hope these three cases make sense now. Case 1, case 2, and case 3. 0 to t. Okay. So if I were to give an example here, say the motion starts from 0 seconds and it lasts up to 10 seconds. So next one would be say 0 to 4 seconds. And what would be case 3? Case 3 would be 4 seconds to exactly 4 to 10 seconds. Write this along with me. Draw this diagram one time, and then below these you can write here case 1, case 2, and case 3. Make a rough calculation based on these motions 0 to 10, 0 to 4, and 4 to 10, and then things would become crystal clear to you. Okay. Now let's directly jump into the application of integration here. So we have case 1, t is equal to 0 to t is equal to t, where the corresponding displacement would be y equal to 0 to y2 equal to y1 equal to 0 to y2 equal to h. Why? What is case 1? Case 1 is the absolute time at which object hits the ground, the complete motion. So what is the result of integration? Tb minus Ta is equal to root 2 by root g into root of y2 minus root of y1. What is Tb? Upper limit, which is t. What is Ta? Lower limit, which is 0. So t minus 0 is equal to root 2 by root g. What is upper limit? H, root of h. Lower limit, root of 0, which is 0. So we get the whole time of travel is root of 2h by g, which actually is something we don't need. Actually, we don't need this for the practical answer here. We just applied what we have learned so far. Now, coming to case 2. T equal to 0 to Tb equal to T1. Upper limit T1, lower limit 0, T1 minus 0. Root of y2 minus y1. Upper limit h by 2, lower limit 0, root of h by 2 minus root of 0. Which gives us T1 is equal to root 2 by root g into root of h by root 2. Root 2 by root 2 is 1, and therefore T1 is equal to root of h by g. Unlike capital T, we need this one for the solution. Okay. Now, case 3, lower limit T1, upper limit T, upper minus lower T minus T1, and not T2 minus T1. Very, very important to note this point. This is very crucial. It is not T2 minus T1. It is T minus T1. The corresponding heights, half of the maximum displacement, h by 2, to the maximum displacement, which is h. Upper limit minus lower limit, root of h minus root of h by 2, which gives us root 2 by g into, now how can you write this root of h by 2 as? Can I split that as root of h by root of 2, which then gives us root of 2 into root of h, root of 2h minus root h by root 2. Root 2 by root 2 is 1. Root 2h minus root h by root g. The LHS is still the same, t minus t1. I can pull out root h common from these two terms. So we have root h into root 2 minus 1, root h by root g. Now, what is root h by root g? We just sometime before we found out that to be t1. Therefore, we have root h by root g as t1 into root of 2 minus 1. I think this is exactly what we're looking for in the answer, right? But then the LHS say t minus t1. And what is t minus t1? So, t is the time taken for the complete travel. T1 is the time taken for half of the travel, the first half of the travel, and T2 is the time taken for the second half of the travel. How can we express T2 as? So T2 would therefore be equal to T1 minus T1. T minus T1. And this exactly is the answer to the question that was asking in the first solution, first part of the solution, the relationship between T1 and T2. So, what is T minus T1? T minus T1 is T2, which is equal to T1 into root 2 minus 1, which is the answer that we're looking for. Okay, so yes, another simple, subtle question, but something which is very important in terms of both applying equations of motion and by solving the question using integration. And what was crucial in that? The limits of which we're trying to analyze the motion. Okay. Now, we are still in the topic motion under gravity, and see, motion under gravity is a very, very important topic because it connects multiple concepts together. And I personally believe that you should be practicing more as far as as much as possible in motion under gravity. And even if you look at the questions that were up for 2025 JEE mains, both the sessions, both of them had very significant percentage of questions connected to motion under gravity, which is the trend that we expect for the next year as well. So practicing these questions will help you not just to solve these ones, but also to understand also to be prepared for. Of course, that's what we are. That is what the entire program is about, right? To be prepared for the next exam by practicing the previous questions. Okay, so let's spend some more time. I think in an estimate it would be close to 6 to 7 hours on this topic, motion under gravity alone, which if you watch in 2x, I think it's a comfortable speed. 2x will be 3.5 hours for you, and we covered a very significant amount of concepts in these 3.5 hours. So yes, that would be, in my personal opinion, that would be sufficient enough. In fact, more than enough to crack JEE main from this topic. Okay. All right. Now, moving on to the next question. Now, this is the one that I was talking about. Visualization is the key to this. So first, let us spend some time to visualize the given motion, and then we'll go into the question.